Hello everyone. Good afternoon to all of you. कैसे हैं आप सब लोग? Audio and video, everything is clear, guys. चलिए चलिए बताइए. Good afternoon everyone. Good afternoon everyone. चलिए. So till now what we have discussed we have discussed about what is Eulerian flow, what is Eulerian approach, what is Lagrangian approach. We started classifying the fluid flow. So that is the first one is the unstudied and studied flow, uniform and non-uniform flow, laminar flow, turbulent flow, transition flow, rotational flow, irrotational flow. Up to this we have completed. So up to this, if anybody having any doubt, they can ask me. Up to this, if anybody having any conceptual doubt, they can ask me. So up to this, if anybody having any doubt, they can ask me. Okay? And you guys are not sharing this lectures. I'm requesting all of you to share this with all your friends so that all your friend and classmate will get benefited. So please share after class or in between class, whenever you want, you can share with your WhatsApp group and all. It will be good for other. रिजल्ट अभी नहीं आया है. इट विल टेक टाइम 2-3 days. मैं आपको बता दूंगा. बट नाउ आई एम फीलिंग ऑलमोस्ट यू कैन से इट्स फिट, बिकॉज मैं क्लासेस ले रहा हूं तो मेरे को लग रहा है कि मैं फिट हूं. ठीक है, चलिए. नोबडी इज हैविंग एनी डाउट. चलिए स्टार्ट करते हैं फिर आज की कहानी. तो आज जो हम बातें करेंगे, टुडे विल टॉक अबाउट, first thing is the very important point, that is the streamline we'll talk about, pathline we'll talk about, streakline we'll talk about, and then we'll start acceleration also. So today we are going to study 4 topic and we'll try to complete it, and after that we'll solve some numerical. So that's it. That's the plan for today, guys. Chaliye. So now those who are new in my lecture, those who are first time watching, for them, my name is Mrigank, expert in GATE, ESE and other technical exam for subjects like environmental engineering, fluid mechanics and open channel flow. And you all know that I have done my master in environmental engineering from NIT Warangal. कल मेरे को बहुत अच्छा एक मैसेज आया बच्चे का कि एक बच्चा में पूछा, सर यू नेवर मेंशन योर बीटेक. बीटेक मेंशन करने का ऐसा नहीं है. आई हैव डन माय बीटेक फ्रॉम ए प्राइवेट कॉलेज इन छत्तीसगढ़. एंड कुछ लोगों को लिए मोटिवेशन है ये, ताकि कोई कहाँ भी किसी भी छोटे कॉलेज या किसी भी प्राइवेट कॉलेज से आप पढ़ रहे हो, दैट डजंट मैटर. इट ओनली मैटर्स इज द गेट रैंक, गेट और ESE, whether you have a job or not, whether you have a desired job or not, that's all. Only that thing matters. आपने कहाँ से बीटेक किया, कहाँ से एमटेक किया, that doesn't matter. But always try to get from a good college so that it will be good for your resume and CV. Clear है? चलिए. Next thing is the right side part, that is my code MR10. You all can use this code not only for the 10% off, but for guidance and support. If you want during your preparation work, then definitely you have to use this, guys. Chaliye. Surprises part, which I already told you, no need to tell it again. You all know that from 5th October FM class will be from 7:30 to 9:30 morning, and the classes will be for 2 hours, as you guys have demanded. Now I'm coming for the 2-hour classes that I already discussed with you. Now this plus subscription is all about those students, those who are very much dedicated about GATE and ESE. They are dedicated about GATE and ESE. Then definitely this plus subscription is beneficial for you. Those guys who want to learn 1 or 2 subject, Unacademy, GATE, CE channel will be best for you. But if you want for a complete package, then definitely you have to go for plus. And those guys who are in 2nd and 3rd year, I think you guys are already aware that we are going to increase the fees in GATE and ESE section. That is the management planning and all. So they are going to increase that. and just a information, I don't know when it will increase, I'm not exact date, I don't know, but it is going to increase. So especially for those second and third year students who are planning to start their preparation in the plus part, I will say take as early as possible ताकि आपको बाद में regret ना हो. चलिए, next thing is the fees. In a plus fees, it is only 22,500, and those students who are very bad in the, I will say very bad in the academics, in that case you have to go for iconic. You have to you will get an analyzer also, you will get a proper, you can say it's like a proper, you can say it's a proper guidance with the official single person will guide you, single faculty will guide you. So ये बहुत अच्छी बड़ी बात है, और जो उनमें करना चाहते हैं then they can go for iconic, otherwise plus will be also you can sufficient for that. चलिए, fees, you all guys are already knowing that debit card and credit card and Bajaj Finance, all EMI option is there. You can go with the EMI option or direct payment. It's the Telegram group, you already know about this group, Telegram Unacademy GATE ESE and CE channel, you already know about this, and most of the guys have already joined also. Unacademy GATE CE channel, these are the channel where we are providing free content on YouTube. Our channel is Unacademy GATE CE, and those who don't subscribe till now, I request all of you to please subscribe so that you will not miss any of lecture, any of my lecture, of any civil engineering lecture. चलिए, तो स्टार्ट करते हैं अपनी कहानी. As I told you that from tomorrow, Saturday, I am going to start the free crash course on environmental engineering, and it will be on YouTube. Unacademy GATE CE channel. It will be on YouTube. So don't worry about the app and all. ये YouTube पे ही रहेगा आपको, and it will be on every Saturday 5 hours. For those students, I am telling you, those who are preparing only for GATE, जो लोग गेट के लिए प्रिपेयर करना चाह रहे हैं उनके लिए ये बेनिफिशियल होगा, नॉट फॉर द ESE एग्जाम. चलिए, any doubt if you have, you can ask me, or else we'll go to the class part. So today, up to rotational and non-rotational or irrotational flow we have discussed. Today we are going to discuss the first flow, that is the nothing but the compressible flow. And incompressible flow. चलिए, अब बात समझिएगा. एवरीवन जस्ट लिसन हियर. अरे अभी भी ये डाउट आप लोगों को क्लियर नहीं हुआ है? गणेश, from 18 to 19 lecture gap नहीं है, from 17 to 18 lecture gap है. That is because of my health. मैंने ऑलरेडी इन्फॉर्म किया था आप लोगों को, ठीक है. चलिए, and don't ask about that syllabus and all. I said that I will complete each and every part. मैं सारे पार्ट कंप्लीट करूंगा, वर्कआउट सेशन भी मैं ले रहा हूं. So don't think about. And some people are asking about, sir, when this FM will complete. I will try to complete in this October, because that is the reason I have increased the number of hour also. चलिए, अब ये सब कहानी मत पूछिए, अब सिर्फ कंटेंट पे आइए. Now come to the content part. चलिए, so first of all, generally people are having doubt that कि compressible flow and compressible fluid are they same? My question is that compressible flow or incompressible flow and compressible fluid and incompressible fluid, are they same? Are they same? Are they same? Yes or no? Yes or no? बताइए. क्वेश्चन इज क्लियर टू ऑल ऑफ यू? कंप्रेसिबल फ्लो एंड इनकंप्रेसिबल फ्लो, या अगर आप बोलो कंप्रेसिबल फ्लूइड एंड कंप्रेसिबल फ्लो, आर दे सेम? आर दे सेम? नो. क्यों नहीं सेम है समझिएगा. कंप्रेसिबल फ्लो मीन्स होता है, फर्स्ट ऑफ ऑल कंप्रेसिबल फ्लूइड मीन्स क्या होता है? कंप्रेसिबल फ्लूइड मीन्स in a fluid where the density is not changing, that's something we call as incompressible fluid. Compressible fluid means density is changing. That's something you told me. Now in a compressible flow, what is happening? This is the flow at this section and this section. Density is same at both the point. Density is constant along the flow. That is nothing but incompressible flow. So incompressible fluid means fluid where in that fluid the density is not changing. That is nothing but we call as incompressible fluid. But during a flow, even an incompressible fluid can act as compressible fluid can act as incompressible flow. Even an compressible fluid can act as incompressible flow. मतलब एक कंप्रेसिबल फ्लूइड जो है वो भी इनकंप्रेसिबल फ्लो की तरह एक्ट कर सकता है, क्योंकि इनकंप्रेसिबल फ्लूइड का मतलब क्या है? डेंसिटी इज नॉट चेंजिंग throughout the length of the flow. I hope it is clear to you. Everyone just write down few line. In case of compressible flow, the mass density is subjected to vary. Due to variation in the volumetric changes, whereas mass density will vary in case of compressible flow throughout the length of flow, along the length of the flow. Once again I am repeating, incompressible fluid means fluid where density is not changing, but it happens that sometime in a compressible flow also, during motion density will not change, and if the density is not changing, that type of thing we call as incompressible flow. तो फ्लो के along अगर आपकी डेंसिटी चेंज नहीं होती है तो उसको आप इनकंप्रेसिबल फ्लो बोलते हैं. अगर फ्लो के along डेंसिटी चेंज होती है तो उसको आप कंप्रेसिबल फ्लो बोलते हैं. इज दैट क्लियर और नॉट? अब बातें समझ में आई? इज दैट क्लियर और नॉट? Is that clear or not? चलिए, I hope it is clear to you. Now we are going to the next term, which is very important, very important for you. That is streamline. समझिएगा. Everyone just listen here for 10 minutes. I want everyone to just listen. I am not looking in the comment section now. प्यार से सुनना पहले, फिर मैं आपको लिखने का टाइम दूंगा. What happens in a flow channel if you are drawing a line or in a curve or whatever you say, if you're drawing a curve or a line, whatever you say, in a such a way that tangent to any point in this curve, will give you velocity direction, of velocity at that point. What I said, that streamline is nothing but it's a curve or a line in a such a way that at any point in that streamline, if you draw a tangent, it will give you the direction of that velocity at that point itself. That's something we call as streamline. Is it clear? तो स्ट्रीमलाइन हमने क्या किया, फ्लो के अलोंग एक मैंने लाइन ड्रॉ की. इट्स अ इमेजिनरी लाइन, इट्स अ कंप्लीटली इमेजिनरी लाइन. So imaginary line I have drawn in a such a way that at any point in this curve or line, if you are making a tangent, it will give you the direction of that velocity at that point. Now many people will ask me, sir क्या streamline पे velocity constant होती है क्या? No. Remember this point. On a streamline, like if you are taking different point, velocity will be different. Velocity can be different. Are you getting my point? So velocity can be different also. But thing is that if you take at any point tangent, it will give you the direction of the velocity at that point. Now, second point. First point, you understood that along a length of flow, if you are making an imaginary line, that's something we are calling a streamline, or that you understood. Now second point, people ask you always that perpendicular to that streamline or cross, you can say flow will occur across a streamline or not. Many people will ask you that. Take an example. For example, this is the velocity. If you take component of this velocity, it will come what? Nothing but is 0. It will come nothing but 0, and that proves you that flow across a streamline will not occur. Second point, you got that? I will give you this point in a written format, but first everyone understand. Flow across a streamline will not occur. So second point you got. Anybody having any problem in this, they can ask me. Clear है? डेफिनेशन में लिखवाऊंगा स्ट्रीमलाइन का, टेंशन मत लो. अभी ये बातें क्लियर हो रही है. जो पॉइंट्स में बोला हूं, आई विल गिव यू इन अ रिटन फॉर्मेट आल्सो. आई विल गिव इट टू यू. चलिए अब दूसरी बात और दूसरे तरीके से समझते हैं. नाउ the streamline is sometimes also called as locus of all the snapshot. Snapshot means it's like a picture. A flow is happening, small picture. It is like a movie. आप मूवी क्या होता है, कई सारे पिक्चर को आप ऐड कर दो तो वो क्या बन जाती है, एक मूवी बन जाती है, एक कंप्लीट मूवी बन जाती है. सेम थिंग हियर. लाइक if I am standing here and you have clicked a picture of me. अब ये जो आप क्लिक पिक्चर की है तो at a particular instance of time बता रहा है ना. So if I am clicking a picture or if I am clicking a snapshot, that is the explanation of a thing at a particular time कि हाँ मैं ऐसे था, but not at every time. Are you getting my point? So streamline is nothing but it's a locus of all the snapshot. ये पूरा combination है snapshot का. At every instance of time, the velocity can be different also with different time. Change भी हो सकता है. For example, today at this point velocity is 5 meter per second. If you come tomorrow at the same point, velocity will be 10 meter per second also. But at that point, the direction will always give you the velocity. The direction of the tangent will always give you the velocity direction. That is constant. Velocity can change. Velocity along a streamline also changes. वेलोसिटी एट दैट पॉइंट इटसेल्फ दैट आल्सो चेंजेस. कल का कुछ अलग होगा, आज का कुछ अलग होगा. आई होप आपको थोड़ी थोड़ी कहानी क्लियर हो रही है. इज इट क्लियर नाउ? इज इट क्लियर अप टू? इज इट क्लियर अप टू? अप टू दिस इट इज क्लियर. ठीक है, चलिए. Some people are asking me, sir, first point. What I said here that every point velocity can be different also. On a streamline, velocity is not constant. Velocity is not constant. It can be different also. That is the first point which I told you. Second point which I told you, second point what I told you that at every point आपकी जो velocity की जो किसी एक point पे जो आपने tangent लिया वो हमेशा आपको velocity का direction दे रहा है. Third point which I told you, across a streamline no flow will occur, because if you take a component of that velocity, the red one, if you take a component of that in a perpendicular direction, it will come as 0, and 0 that means no flow is occurring across a streamline. I hope it is clear to all of you. चलिए थोड़ी सी बातें और करते हैं. अब बताइएगा, क्या दो स्ट्रीमलाइन एक दूसरे को क्रॉस कर सकते हैं? My question is that can two streamline can cross each other? Can two streamline can cross each other, or a single streamline can cross itself या intersect itself? क्या एक ही स्ट्रीमलाइन अपने आप को कट कर सकता है या दो स्ट्रीमलाइन इंटरसेक्ट कर सकते हैं? क्या ऐसा पॉसिबल है? इज दैट पॉसिबल? यस और नो? यस और नो? चलिए, तो बातें हम कर रहे थे स्ट्रीमलाइन की. आपने बोला क्रॉस कर सकता है ये नहीं. फॉर एग्जाम्पल दिस इज द सेकेंड स्ट्रीमलाइन. Now at the point of intersection, if you try to make a tangent, two tangent will be drawn, but एक point पे दो velocity possible है क्या? Is it possible at a point two velocity will be possible? No. That is the reason dear, एक streamline खुद को भी कट नहीं कर सकता, साथ में किसी दूसरे को भी कट नहीं कर सकता. So no two streamlines can intersect each other, or not even a single streamline can intersect itself also. ये खुद को भी intersect नहीं कर सकता. Is that clear? Because at a point if two streamline will come, two velocity will be there. एक point पे दो velocity not possible. Is that clear to all of you? चलिए, अब आप लोगों से कुछ लोग डेफिनेशन लिखने की जल्दी है, तो पहले डेफिनेशन लिख लो आप. Some of you guys are very much. चलिए, तो आप लोग में से कुछ लोगों को है कि सर डेफिनेशन लिख दिया करो. चलिए लिखो डेफिनेशन. चलिए लिखिए एवरीवन डेफिनेशन राइट डाउन. It is an imaginary line. Or curve drawn in a space such that tangent drawn to it at any point will give the direction of velocity at that point. Will give you the direction of velocity at that point. So this is the definition. This is the definition. Second point which I told you that streamline is an instantaneous snapshot of flow. Streamline is an instantaneous snapshot of flow. चलिए कॉपी कर लिया है आप लोगों ने, आई होप. नेक्स्ट पॉइंट कॉपी कर लिया. Have you guys copied? Have you guys copied? Thank you, Saurabh. Thank you, Saurabh. Still I am learning, guys. Still I am learning. Even though मैं 4 सालों से पढ़ा रहा हूं, but still I am learning from all of you. Aman, please read the definition once. Please read the definition once. जो आप डाउट पूछ रहे हो एक बार में क्लियर हो जाएगा. It is an imaginary line or curve drawn in a space such that a tangent drawn to it at any time, at any point, will give the direction of velocity at that point itself. ठीक है. Second point, what I told you, that streamline is nothing but it's an instantaneous snapshot of flow. Next point. There is always flow along the streamline and there is no flow occur across the streamline. Next point. No two streamline can intersect or a single streamline. No two streamline can intersect or a single streamline intersect with each other. No two streamline can intersect or a single streamline can intersect with each other. Because at any point two velocity is not possible. Two velocity is not possible. चलिए, I think up to this you have copied. एफएम इन्वायरमेंट जितना इंटरेस्टिंग क्यों नहीं है? नाइस क्वेश्चन, क्योंकि एफएम में ज्यादा दिमाग लगता है, इट्स इमेजिनेशन, यहाँ पे आपकी भी इमेजिनेशन लगती है, दैट इज द रीजन उतना ज्यादा नहीं है, और इन्वायरमेंट में इमेजिनेशन कम लगती है एज कंपेयर टू फ्लूइड मैकेनिक्स। ठीक है, फिगर वाला पेज करूं, चलिए एवरीवन नोट इट डाउन, नोट इट डाउन, नोट इट डाउन। थर्ड पॉइंट रिवाइज कर दो। थर्ड पॉइंट कौन सा? There is always flow along a streamline and there is no flow occur across a streamline. You can see here dear, ये जो velocity है सिर्फ इसी along चल रही है ना, इसके perpendicular अगर आप across में अगर बात करोगे, across if you are taking, there will be no velocity because component of that velocity will be zero. Perpendicular component का क्या होगा? Zero होगा, normal component. So in that case there is no flow occurring across the streamline. There is no flow is occurring across the streamline. That is your third point. This is the point. चलिए थोड़ा सा एफएम में पेशेंस दिखाना पड़ेगा, दैट इज द रीजन एफएम में बच्चे ज्यादा स्कोर नहीं कर पाते, क्योंकि पेशेंस नहीं होता। लिटिल बिट पेशेंस इज रिक्वायर्ड इन फ्लूइड मैकेनिक्स। चीजें स्लो स्लो समझ में आएंगी, लेकिन एक बार समझ में आएगा तो फिर दिमाग में रहेगा। चलिए 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 एवरीवन, अप टू दिस कंप्लीटेड, अप टू दिस कंप्लीटेड, up to this completed। ठीक है, चलिए थोड़ी सी और बातें करते हैं। समथिंग मोर डिस्कशन आई एम डूइंग, समथिंग मोर डिस्कशन आई एम डूइंग। लुक एट हियर, if I will draw a streamline here, 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 it will be like this। What you have noticed here, what you have noticed here, what you have noticed here, at this point if you guys have noticed, all the streamline, the blue line is nothing but the streamline, all the blue lines are converging। मतलब यहाँ पे क्या हो रही है आपकी, आपकी क्या हो रही है, जो spacing between the streamline that is getting reduced, that is getting reduced। So that is indication for you, that is the indication for you that your velocity is increased। अगर आपकी वेलोसिटी इंक्रीज हो जाती है तो आपके कई सारे स्ट्रीमलाइन एक जगह आ जाते हैं। द स्पेसिंग बिटवीन द स्ट्रीमलाइन विल गेट रिड्यूस्ड, द स्पेसिंग बिटवीन द स्ट्रीमलाइन विल गेट रिड्यूस्ड। as you can see the velocity is getting down, the spacing between the streamline is increasing, the spacing between the streamline is increasing। So this is also one of the good question that people can ask you, that when velocity will increase spacing will go down, well velocity will decrease spacing will increase, velocity will decrease spacing will increase। तो जब स्पेसिंग बढ़ रही है स्ट्रीमलाइन के बीच में मतलब वेलोसिटी बढ़ रही है, दैट्स द इंडिकेशन फॉर यू, दैट्स द इंडिकेशन फॉर यू। सो यू गाइस कैन राइट इट डाउन, you guys can write it down for the next point। आप लोग next point पे लिख लीजिए। everyone write down, everyone write down as a next point, everyone write down as a next point, everyone write down as a next point। the spacing between the spacing between the streamline, the spacing between the streamline streamline will decrease at the converging point, will decrease towards the converging point, towards the converging point, towards the converging point. ठीक है, फर्स्ट पॉइंट हो गया. सेकेंड पॉइंट, the spacing between the particle, spacing between the streamline increases when velocity increases, when velocity decreases, when velocity decreases. तो स्ट्रीमलाइन की स्पेसिंग बढ़ती है जब वेलोसिटी घटती है. Remember this point. Remember this point. These 2 points are very important for you. These 2 points are very important for you. These 2 points are very important. That spacing between the streamlines will decrease towards the converging point. The spacing between the streamline will decrease towards the converging point. स्पेसिंग देखो घट रही है, आपको कन्वर्जिंग पॉइंट्स की तरफ जैसे ही बढ़ रहा है वो घट रहा है, और स्पेसिंग इंक्रीज करेगी व्हेन वेलोसिटी इज डिक्रीजिंग. सो दिस टू थिंग यू कैन नोट इट डाउन. दिस टू थिंग यू कैन नोट इट डाउन. दिस टू थिंग यू कैन नोट इट डाउन. बात समझ में आई? बात समझ में आई? किसी को इस बात में प्रॉब्लम? एनीबडी हैविंग एनी प्रॉब्लम? एनीबडी हैविंग एनी प्रॉब्लम? चलिए अब बातें करते हैं हम अपने दूसरा दैट इज नथिंग बट द पाथ लाइन. पाथ लाइन, दैट इज नथिंग बट द पाथ लाइन. नाउ व्हाट इज पाथ लाइन? व्हाट इज पाथ लाइन? चलिए, तो फर्स्ट ऑफ ऑल Pathline actually follows Lagrangian approach. आप बोलोगे सर कैसे, क्या हो गया, क्या है ये? देखिए, what happens at particular point, this all particles are going at this point. Second point is this one. 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 So this at this point temperature is T1, T2, T3, T4, T5. These are the time, different time. Particles is same. अब एक पार्टिकल्स अभी आपको यहाँ है, दूसरा उस दूसरे टाइम में यहाँ है, तीसरे टाइम में यहाँ है, चौथे टाइम में यहाँ है, पांचवें टाइम में यहाँ है. That means with the time the particles position and velocity both are changing. So if you draw a line which joins the locus of movement of same point, that's something we call as path line. So in this path line, which approach we are following? Lagrangian approach, because I told you in a Lagrangian approach what we are doing, every fluid particle we are analyzing. So particle analysis is there. So here you can see that in a path line, एक particle को लिया, वो जहां move कर रहा है, as it is moving, the line is going like this only. The line is going like this only. If the particles are going, next point is this, particle will turn like this. Next point is this one, particle will turn like this. So ये हो रही है, and same time it can happen that particles will come here, again particles will come here. So the movement will be this one, again this one, again this one. So it is keep on moving. So if you look at this curve which is formed by joining all the location of the same particle same है, particles different नहीं है, particles are same. तो आप बताना कि यहाँ पे क्रॉस करना अलाउड हो गया, क्यों अलाउड हो गया? Why crossing is allowed here? Why crossing is allowed here? Why intersecting is allowed here? आप देख सकते हो डायग्राम में, one path line is intersecting itself, खुद को इंटरसेक्ट कर रहा है वो, इवन वो दूसरे को भी इंटरसेक्ट कर सकता है, दूसरे पाथ लाइन को भी इंटरसेक्ट कर सकता है. दैट इज पॉसिबल. हाउ? Because you are analyzing a single particle motion, and you don't have taken anything, you don't have taken any assumption that on that curve tangent will give you velocity and something. कुछ भी हमने ऐसा नहीं सोचा. तो हम क्या कर सकते हैं, ये पार्टिकल अलग अलग जा रहा है, तो अगर पार्टिकल यहाँ पे आपको मिल रहा है, इंटरसेक्ट कर रहा है, तो वहां एक ही पार्टिकल है, वहां दो पार्टिकल नहीं है, इट इज ओनली वन पार्टिकल. So in one particle, one velocity will be there. That's something we can count it. So at a point, at the intersection point, two velocity is not generating here. Two velocity is not coming. So in that case, intersection is possible. Intersection of path line is possible. Intersection of path line is possible. ये बात समझ में आई? हाँ या ना? Whether this point is clear or not, I'm asking to all of you. क्या ये बात समझ में आई या नहीं आई? When they will intersect, timing will be same? No, timing will same नहीं होगा. जब आप यहाँ पे थे dear, when you are here, timing कुछ अलग थी ना. This is time 5, this is time 6, this time 7, this is time 8, this is time 9, this is time 10, this is time 11. So time is different. Time is different. Is it clear? तो path line और streamline में difference समझ में आया? You got the difference between the path line and streamline. Path line follows Lagrangian approach. That means single fluid particles approach it is following. And that in that case, path line can cross each other. So everyone just write down few lines regarding path line. सब लोग थोड़ा सा लिख लीजिए, path line को अच्छा लगेगा. Everyone write down the path traced by a single fluid particle at single fluid particles at different instant of time during a flow is known as pathline. Chलिए, so anybody having any problem in this? Anybody having any problem in this? You can ask me. Path line हम किस लिए बनाते हैं? Just to see the motion of, or just to analyze the fluid motion of a single fluid particle. Path line सिर्फ हम theoretical बातें करेंगे. There will be no mathematical discussion for path line. Clear है? Is that clear? Is that clear to all of you now? चलिए, अब बातें करते हैं हम लोग streak line की. Now we'll talk about next line, and if you want you can note it down the second point also. Path line can cross each other. Path line can cross each other. So is it imaginary, or that path itself known as a path line? That path itself is known as a path line. It is not imaginary. That path itself is known as a path line. it's not imaginary. आपका streamline, that is the imaginary, completely imaginary. But this path line, it is possible. If you draw that, it is possible. ये naturally होता है. एक पार्टिकल को आप देखोगे ना, तो वो पार्टिकल जैसे जैसे जा रहा है, that is nothing but the path line. That is nothing but the path line. Clear है? Streamline क्यों बनाई है? Many people are asking, sir, even though streamline is imaginary, why we made this? Streamline हमने क्यों बनाया? That I will tell you when I will tell you the equation of streamline. Actually, streamline जो है ना, that helps you in analyzing the flow, and that is the reason we made this streamline. That is the reason we made this concept something we call as streamline. Is it clear? Is it clear? चलिए. Now, before going to the streak line, I just want to tell you the first, that is the equation of streamline. Equation of streamline. Equation of streamline. बहुत प्यारी इक्वेशन है, देखिए. ये आपका स्ट्रीमलाइन है. At a particular time, if you are looking, distance travel is dy in y direction, in x direction is dy, and this is dx. So if you find out velocity in x direction, it will be dx upon dt. In a y direction, it will be dy upon dt. I don't think so anybody will have any problem. Now, if you take a ratio of this, आपको क्या आएगी? U by v will be equal to dx by dy. मैंने इन दोनों का रेशियो ले लिया. I have taken ratio of these two. That's something I can write as dx upon u will be equal to dy upon v. And this is nothing but the equation of streamline. इसको आप क्या बोलते हो? Equation of streamline. That's something we call as equation of streamline. And if you write this is for 3D, and if you write this equation for 3D, nothing will change. For 3D, equation of streamline will be dx upon u, dy upon v, and dz upon omega. Anybody having any problem in this equation, they can tell me, because this equation is very, very important for you. Mostly we will use 2D equation, 3D equation we will not use, but this equation is very important. चलिए, क्लियर हुई बातें? Is that clear to all of you? So now some people are asking about, sir, why we are studying, or why we are giving this streamline. एक नया term क्यों लाया हमने? Because it helps in analyzing the flow. Now you can see that with the help of equation of a streamline, you can analyze the flow. Dx upon u will be equal to dy upon v will be equal to dz upon the omega. Is it clear now? Yes or no? Is it clear? Chali. If it is clear, then please note it down fast. Please note it down fast. Sometime a streamline flow we also call as organized flow. Streamline मतलब एक properly lining में flow हो रही है. That means it is nothing but organized flow. तो हम लोग organized flow भी इसको बोलते हैं in some situation. चलिए, I hope you have noted down. Next one is the streak line. Streak line. चलिए अब स्ट्रीक लाइन को समझते हैं क्या है. विल अंडरस्टैंड व्हाट इज स्ट्रीक लाइन. How is the streamline different from the laminar flow? अरे बच्चा, laminar is a condition of flow. Streamline is nothing but it's a line. दोनों different हैं. Both the concept itself is different. Is it clear? Laminar, turbulent, transition. These are the flow condition. These are the flow condition. ठीक है. Streamline is nothing but streamline is possible in laminar also. Streamline is possible in turbulent also. Are you getting my point? Are you getting my point? Especially for you, Ankan. Chali. Now, before telling the streak line, before telling or explaining about a streak line, I just want to write that definition first. A streak line is the locus of various particles passing through a fixed point चलिए अब आपको डेफिनेशन से अगर समझ में नहीं आया, बिकॉज मेनी पीपल विल हैव डाउट अबाउट स्ट्रीक लाइन, तो समझते हैं स्ट्रीक लाइन होता क्या है. एवरीवन जस्ट लिसन हियर. देखिएगा स्ट्रीक लाइन क्या होता है, एक बार में क्लियर होगा, दोबारा कभी आपको डाउट नहीं होगा. स्ट्रीक लाइन में, पाथ लाइन में, nobody will have any doubt. For example, this is the pipe. What is flowing from this pipe? ठीक है. Now from this point, all the particles are going. So for example, take an example of a particle. एक पार्टिकल हो गया. So at point T1, T2, T3, T4, T5, T6, ये जो लाइन मैं ड्रॉ कर रहा हूं, this line which I am drawing, tell me, is it a path line, is it a streak line, or what? Is it a path line, streak line, or what? My question is to all of you, it is a streak line, path line, or streamline? कौन सी line है? Everybody just listen here, then your doubt regarding streak line will get clear. My question is that the line which I have drawn right now, the curve which I have drawn right now, by joining all the points, all the particles, that is nothing but a path line or a streak line. वो path line है या streak line है? बताइए, साथ में बताइएगा, 2 मिनट में क्लियर हो जाएगा आपके डाउट. Within 2 minutes your doubt will be clear. Path line, very good. चलिए, similarly यहां से एक और पार्टिकल निकला. That particle is going in this direction. Now at time T1, T2, T3, T4, T5, T6. That is also nothing but a path line. At the same time, a different path, a different particle time again T1, T2, T3, T4, T5 and T6. All are nothing but the path line. Now what is streak line? Remember, at any point, look at here. At any point, this is nothing but the streak line. ये आपका क्या है? Streak line. This is nothing but streak line. ये आपका क्या हो जाएगा, स्ट्रीक लाइन। ये जो लाइन आपने ड्रॉ किया रेड लाइन, दैट इज नथिंग बट स्ट्रीक लाइन एट a particular time t3, at a particular time t3. If you make this at particular time t2, it will be like this. It will be at t1, it will be like this. At t4, it will be like this. At t5, it will be like this. That's something we call as streak line. At a particular point, locus of various particle, those particle, लेकिन सारे पार्टिकल कहां से पास होने चाहिए, एक सिंगल पॉइंट से, इसी सिंगल पॉइंट से सारे पार्टिकल्स आए हैं. From this single point only all the particles came. So now you got idea about what is streak line, what is path line. You got the difference also. Yes or no? Yes or no? I'm asking to all of you. क्या यह बात समझ में आई या नहीं आई? Have you got the idea or not? Have you got the idea or not? I'm asking to all of you, बच्चा, please reply. Have you got the idea or not? समझ में आया क्या होता है streamline? What is streakline? What is streamline? All these lines you have understood. All these lines you have understood. क्रिस्टल क्लियर हुआ कि नहीं? क्रिस्टल क्लियर हुआ कि नहीं? क्रिस्टल क्लियर है? चलिए, वेरी गुड. अब आई होप यू हैव नोटेड डाउन ऑल्सो. आई होप यू हैव नोटेड डाउन ऑल्सो. अब एक पॉइंट है जो आपको बहुत बार लोग पूछेंगे एंड somebody will ask you to explain also. First I am giving the statement, then we will see whether this statement is correct or not. In a steady flow, listen here, in a steady flow, streamline, streakline and pathline all will coincide each other. All will coincide each other. In a steady flow, streamline, streakline, pathline, all will coincide each other. My question is that, is it possible or not? Is it possible or not कि ये चीजें जो मैं आपको स्टेटमेंट लिखा, is it right or wrong? Is that statement is right or wrong? At a particular time you can draw the streak line. At a particular time you can draw the, at a particular time all the different particle, if you join that particle, that is nothing but the streak line. That is nothing but the streak line. Clear है? अभी मैंने जो आपको स्टेटमेंट लिखी, is that right or wrong? चलिए, तो सर आप तो स्टेटमेंट लिख दियो, बताए तो हो नहीं, समझाए तो नहीं, तो कैसे पता चलेगा कि ये राइट है या रॉन्ग? चलिए, तो we'll try to understand this. We'll try to understand this. We'll try to understand this. चलिए, ध्यान से देखिएगा एवरीवन. This is your streamline. This is your streamline. First, let me draw, then you can draw after that. First, let me draw, then you can draw after that. Chaliye. So this is nothing but the streamline. This is nothing but the streamline. At this point, all particles are passing. From this point, all particles are passing. So what happens? One particle is going like this. another particle is going like this, another particle is going like this, another particle is going like this. Chaliye. Now you guys will tell me this red line, this yellow line, this green line, this white line are path line or a streak line? 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 You guys will tell me that these lines are path line or a streak line. जल्दी बताइए, जल्दी बताइए. चलिए, these all lines are path line. You will ask, sir, why at the same point all particles at the same point, this is the point, all particles are passing through that same point, but why every particles are having different you can say the path line? Why? Because if the flow is unsteady, every time the speed will be different, and because of that, different particles at a different point, they will take different velocity, and it will make a different path line. वो different path line बना रहा है, different path line बना रहा है. But once that flow will become steady, और अभी unsteady भी flow है, तब भी आप देखो, if you want to draw, I don't have new color now. कौन सा कलर यूज करूं? रेड वन यूज करता हूं. So this one is nothing but the streak line at a particular time. If you want to draw, so the line joining all the particles will be nothing but the streak line. Ab, if the flow is steady, in that case every point at every particular point the speed and the velocity will be same. और जब सबकी स्पीड सेम होगी तो ये चार पाथ लाइन बनेंगे क्या? Are you getting my point? अगर सबकी स्पीड सेम होगी, the flow is steady, do you really think this four path line will form? Do you really think this four path line is formed? This four path line is formed. Why? Because at a different instant of time, the velocity component is different. And because of this, different particle will have different path line. But once the flow becomes steady at a particular point, all are passing through the particular point. What happens? That कि आपके सारे particle क्या करेंगे? It will go through this point only. So you can see here that all path lines are coinciding with the streak line, and streak line, path line, all are already on the streamlines. तो तीनों एक जगह क्या हो गए? Coincide हो गए. So this happens only when flow is steady. I hope it is clear. I hope it is well explained to you. If you have any doubt, you can ask me. अगर आपको कोई डाउट है तो पूछ लीजिए. If you have any doubt, you can ask me. चलिए, if you have any doubt, you can ask me. समझ में आया? When the flow will be steady, all these path line will pass through the streak line only. Why? Now the velocity is same. These path lines are formed only because there is a variation in the velocity, variation in the variation in the particles, fluid particles properties. और अगर ये चीजें नहीं हो रही हैं तो डेफिनेटली वो सारे एक ही जगह से पास करेंगे. एंड इन दैट केस द स्ट्रीक लाइन, द पाथ लाइन, द स्ट्रीम लाइन, all are at the same line. and that's what I told here. यही मैंने आपको बोला था. In a study flow, streamline, streakline, pathline, all will coincide each other. That is the only thing I told you. चलिए, क्लियर हुई बात? Is that clear to all of you? Sometime this point they can ask you for 1 mark. Sometime they can ask you this point for 1 mark. 1 mark के लिए आपसे पूछ सकता है sometime. Samar is telling sir, what is streamline? Amma, Samar, I have already explained you streamline. अब definition मत पूछो मेरे से. I think you have just now joined. I have already explained what is streamline, what is streakline, what is pathline. That part I have already explained you. Clear hai? I hope it is clear to all of you. Anybody having any doubt, they can ask me now. चलिए चलते हैं हमारे नेक्स्ट टॉपिक में. सो आफ्टर I think you all guys are very much clear now about streakline, streamline और pathline. बिल्कुल clear है. Just for your hint, I have already given you that we have mathematical calculation something related with the streamline, but we don't have any mathematical calculation with the streakline and pathline. इन दोनों के लिए हमारे पास कोई mathematical calculation नहीं है. It's the only visual thing. It's only visual thing. ठीक है? We don't have any mathematical analysis for that. We don't have any analytical analysis for that. चलिए. So the next topic is acceleration. Next topic is acceleration. अब आपने बचपन से पढ़ा होगा what is acceleration, what is acceleration. आपने बचपन से पढ़ा होगा. So for example, one particle is this. Location coordinate of this particle is x1, y1, z1. This is x2, y2, z2. Basic thing I'm writing here. If I am writing velocity vector, it will be uy bar, vj bar, omega k bar. Similarly, if I am writing acceleration, it will be axi plus ayj bar plus azk bar. Basic thing. ठीक है? चलिए. Now if I will write what is u, that is dx upon dt. What is v? That is dy upon dt. What is omega? That is dz upon dt. First I am writing all the basics for you. चलिए देखिए यहाँ पे. Now if I am writing ax, that means it is du upon dt. If I am writing ay, this means it is du upon or dv upon dt. If I am writing az, d omega upon dt. Up to this, anybody having any problem in the basics part? They can ask me. जल्दी बताइए. Up to this, anybody having any problem in the basic part? They can ask me. चलिए, अब बेसिक बातें फिर से. If I will take an example of u, मैंने पहले आपने ax निकाल के दिखाना है. पहले आपको ax निकाल के दिखा रहा हूं. So if I am taking example of u, it is a function of x also, y also, z also and t also. It can be function of x, y, z, t. सारे का फंक्शन हो सकता है. Now many people will ask me, sir, u तो आपने जो बताया that is dx upon dt. How can that velocity will be function of x, y, z and time? Beta, I am taking 3D flow. What is the meaning of 3D flow? That any component will be dependent on the three variable x, y, z. तीनों कंपोनेंट आपके जो है वो तीनों 3 पे वैलिड हो सकते हैं. टाइम इज द एक्स्ट्रा पार्ट. इज दैट क्लियर? क्लियर है? अरे बच्चा, बिना थ्योरी के आप प्रॉब्लम नहीं बना पाओगे. फर्स्ट एटलीस्ट 2-3 क्लास तो थ्योरी पढ़ना पड़ेगा ना. बिना थ्योरी के प्रॉब्लम थोड़ी बनेगा. चलिए, so u is a function of x, y, z and t. So now you have to differentiate with respect to t. आपको x के रिस्पेक्ट में dt के रिस्पेक्ट में डिफरेंशिएट करना है. कैसे करोगे? ax will be a partial differentiation now. It will be a partial differentiation now. Yes or no? अब पार्शियल डिफरेंशिएशन जिनको आती है उनको ये चीजें बिल्कुल समझ में आएगी. जिसको नहीं आती है वो बोलेंगे सर क्या हो गया. Those guys who are knowing partial differentiation, they are very much comfortable with this. I am doing partial differentiation. क्या होगा? du upon dx into dx upon dt plus du upon dy into dy upon dt plus du upon dz into dz upon dt plus du upon dt into dt upon dt. So if I will write ax here, now dx upon dt को मैं क्या लिख सकता हूं? u लिख सकता हूं. Yes. So dx upon dt I can write as u double u upon double x plus dy upon dt को मैं v लिख सकता हूं. So v del u upon del y plus dz upon dt को मैं क्या लिख सकता हूं? ओमेगा लिख सकता हूं. तो ओमेगा del u upon del z. Now here delta t और delta t वाला पार्ट कैंसल. So you are only with del u upon del t. चलिए, so मैं आपके लिए एक जगह लिख देता हूं that ax we got is u du upon dx plus v dv upon dy plus omega कहाँ u लिखाना चाहिए, सॉरी. So this will be u upon del y omega del u upon del z plus del u upon dt. So this formula we got for ax, that is the acceleration in x direction. I hope it is clear to all of you. If you want you can note it down. If you want you can note it down. If you want you can note it down. चलिए, everyone note it down fast. Everyone note it down fast. चलिए सब लोग नोट कीजिए, आराम से नोट कीजिएगा, कोई जल्दी नहीं है. इफ पॉसिबल आई वांट यू टू डिराइव ऑल्सो. मेरे साथ ही डेरिवेशन कर लीजिए. इट विल बी इजी फॉर यू टू रिमेंबर. इट विल बी इजी फॉर यू टू रिमेंबर. जल्दी बताइए कमेंट में, इज इट डन? इज इट डन? चलिए चलिए, वेरी गुड वेरी गुड वेरी गुड वेरी गुड. Now similarly if I will ask you to write down for ay, कैसे क्या लिखोगे? ay will be equal to u into dv upon dx plus v dv upon dy plus omega dv upon dz plus del v upon del t. Similarly, for az it will be u into del omega upon del x plus v omega upon y plus omega del omega upon del z plus del omega upon del t. Anybody having any problem, they can tell me, or if not, then please copy fast. Please copy fast. Please copy fast. Please copy fast. So this part we call as इस part को आप क्या बोलते हो? Convective acceleration. And this part you call as local या temporal acceleration. So the space part, when the velocity is changing with the space, that acceleration we are calling as convective acceleration. When the velocity is changing with the time, that's something we call as local or temporal. Temporal, temporal acceleration. Please note it down that. 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 Now total acceleration, if somebody is asking you, it will be summation of convective acceleration plus. So I'm writing here total acceleration will be equal to convective acceleration plus local or temporal acceleration. I hope it is clear to all of you. आप सबने नोट कर लिया? I hope आप सबने नोट कर लिया है. चलिए नेक्स्ट समझते हैं. छोटा सा एक टेबल बना रहा हूं आप लोग के लिए. आराम से पहले टेबल बना लीजिएगा सब लोग. Type of flow, convective acceleration, LA. CA is convective acceleration, LA is local acceleration. चलिए फर्स्ट केस स्टडी एंड यूनिफॉर्म फ्लो. सेकंड केस unsteady and uniform flow. Next case steady and non-uniform. Next one is non-uniform and non or unsteady. ठीक है. चलिए अब फटाफट बताते जाइए आप सब लोग, कमेंट सेक्शन में मेरे को बताते जाइए सब लोग। ये बहुत ही इंपॉर्टेंट टेबल है, दिस इज वेरी 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 आई विल से इंपॉर्टेंट टेबल फॉर यू। इफ यू वांट मेक इट, यू कैन गिव इट एज मेनी स्टार एज यू वांट। चलिए बताइए स्टडी एंड यूनिफॉर्म फ्लो के लिए, फॉर स्टडी एंड यूनिफॉर्म फ्लो whether CA will be 0 or not equal to 0, it will be 0 or non-zero. I'm asking for CA and LA, CA and LA for study and uniform flow, it will be 0 or non-zero, only I want 0 or non-zero. बताइए everyone, it will be 0 or non-zero, I want only that. First for study and uniform flow, it will be 0 or non-zero, सिर्फ इतना बताइए। और अगर सारे केस का बताइएगा तब तो और भी मजा आएगा, अगर आप सारे केस का बताइएगा तब तो और भी मजा आएगा। स्टडी में लोकल एक्सेलेरेशन क्या होगा? स्टडी मतलब विथ रेस्पेक्ट टू टाइम, दैट विल बी 0, सो लोकल एक्सेलेरेशन विल बी 0, वेरी गुड। कन्वेक्टिव एक्सेलेरेशन यूनिफॉर्म भी है, दैट मींस विथ रेस्पेक्ट टू स्पेस देयर विल बी नो चेंज। व्हाट इज द मीनिंग ऑफ यूनिफॉर्म फ्लो? विथ रेस्पेक्ट टू स्पेस देयर विल बी नो चेंज। यू कैन सी इन द कन्वेक्टिव एक्सेलेरेशन आइदर x के रिस्पेक्ट में, आइदर y के रिस्पेक्ट में या z के रिस्पेक्ट में, ऑल आर नथिंग बट द स्पेस, सो इन दैट केस दैट विल बी आल्सो 0। Unsteady and uniform flow, now unsteady, that means local acceleration can be possible, so this will exist. But what about convective acceleration? It will be still 0. Steady and non-uniform, so local acceleration 0, non-uniform, so it will be existing. Non-uniform मतलब आपको du upon dx जो है या du upon dy जो है वो एग्जिस्ट करेगा, non-steady and non-uniform flow both will exist, very very important table for you. Please not only copy, please copy this in your mind, not in your notebook, please copy this in your mind. कई बार 1 मार्क का क्वेश्चन पूछ देता है, कई बार आपको प्रॉब्लम्स में यूज होगा, so many places it will be going to use, so I want everyone to please copy this thing in your mind, अपने माइंड में डाल लो। Is that clear? Is that clear to all of you? Is that clear to all of you? Is that clear to all of you? चलिए एक क्वेश्चन फटाफट सॉल्व, एक क्वेश्चन बताइएगा। दिस इज द क्वेश्चन गाइस, आई वांट यू गाइस टू सॉल्व इट। दिस इज द क्वेश्चन गाइस, आई वांट यू गाइस टू सॉल्व इट। एवरीवन टेल मी। Tell me, I want everyone to comment. What will be your answer? What will be your answer? चलिए सबसे पहले इन अ फ्लो फील्ड the streamline and equipotential line. So many of you are not knowing what is equipotential line. अगर आपने flow net पढ़ा होगा, if you guys have studied flow net in soil mechanics, आपका soil mechanics I think complete हो चुका है. So if you have studied the flow net, आपको मालूम होगा equipotential line क्या होती है. It is passing or you can say perpendicular to the streamline. ये हमेशा क्या होता है, perpendicular to the streamline होता है. But not at every places. ये जो आपको डाउट है ना, कई लोग सी जो ऑप्शन बता रहे हैं, not at every places. स्टैग्नेशन पॉइंट एक चीज होती है, स्टैग्नेशन पॉइंट एक चीज होती है. रिमेंबर दिस, व्हाट इज स्टैग्नेशन पॉइंट? At any point where forcefully you are making that velocity zero, where forcefully you are making that velocity zero. So at that point we call as stagnation point. जहां पे आपने forcefully velocity zero किया है. For example, if you are throwing a water on a wall, so when that water will hit that wall, at that point of hitting, the velocity will be zero. So that point we call as stagnation point. That point we call as stagnation point. So at that point, if the velocity is zero, can you tell me, can we draw the streamline at that point? If that point the velocity is zero, can you draw that streamline? Yes or no? Can you draw that streamline? I'm asking to all of you. If this is your streamline, those who don't know, this will be the equipotential line having same potential, but इसके across flow नहीं होता. Flow आपको इसके across होती है. फ्लो आपको स्ट्रीमलाइन के अलॉन्ग होता है. अक्रॉस आपको फ्लो नहीं होगी. दिस इज योर इक्विपोटेंशियल लाइन. इट विल मीट ऑलवेज परपेंडिकुलर. ये हमेशा परपेंडिकुलर ही मीट करेगा. एंड दैट आल्सो आई विल प्रूव यू व्हाई. इन द लेटर डिस्कशन आई विल प्रूव यू व्हाई. बट राइट नाउ आई वांट यू टू अंडरस्टैंड व्हाट इज स्टैग्नेशन पॉइंट. आपको स्टैग्नेशन पॉइंट वाली कंसेप्ट समझ में आई या नहीं आई? Have you understood the stagnation point concept or not? That is the only thing I am asking to you now. Clear hai? I hope it is clear. I hope stagnation point concept is clear to you. So answer will be D. It cut orthogonal except at the stagnation point. Stagnation point पे आप streamline ही draw नहीं कर पा रहे हो. How can you make them orthogonal? So at a stagnation point, velocity is zero. You will not be able to make a streamline. In that case, D option will be most appropriate option. I hope it is clear to all of you. We are going to the next question. Try this one. Question. Everyone try this one question. What is equipotential line? Line having same potential. Every point the potential will be same. The potential energy will be same. And that line crosses the streamline. That you have discussed in geotech. Geotech में आपने एक टॉपिक पढ़ा होगा, flow net. यही होता है flow net. This is something we call as flow net. वहां आपने इक्विपोटेंशियल लाइन और स्ट्रीम फंक्शन लाइन स्ट्रीमलाइन दोनों आपने पढ़ा होगा. So equipotential line is something which you have already discussed in the geotech part. ठीक है जय सूर्या. चलिए बताइए नेक्स्ट क्वेश्चन. For a certain two-dimensional incompressible flow, it is incompressible. Incompressible flow, velocity field is given by 2xy I bar minus y square j bar. The streamline for the flow are given by the family of curves. That is 4 option is given to you. Basically, you have to find out the equation of a streamline. स्ट्रीमलाइन का कंसेप्ट क्लियर नहीं है पूरा। स्ट्रीमलाइन का कंसेप्ट आपको मैंने अभी बता दिया, जितनी भी चीजें आपको स्ट्रीमलाइन से रिक्वायर्ड थी, आई हैव टोल्ड यू अबाउट इक्यू पोटेंशियल लाइन। मैंने आपको बताया दैट लाइन हैविंग सेम पोटेंशियल एंड इट विल पास थ्रू द और इट विल पास थ्रू ऑर्थोगोनली विद द स्ट्रीमलाइन। ये मैंने आपको बता दिया। this you can the net which is formed this we call as flow net। ये चीजें आपने पढ़ा होगा जियोटेक में इन सीपेज एनालिसिस में आपने पढ़ा होगा। क्लियर है? चलिए क्वेश्चन बनाइए सब लोग। It's a very easy question. You all guys can attempt. Velocity is given to you, that is 2xy I bar minus y square j bar. That means u will be 2xy, v will be minus y square. Chaliye, we'll put this in a streamline equation. That is dx upon u will be equal to dy upon v. So dx upon 2xy will be equal to dy upon y square. Now y and y will get cancelled out. You are remaining with dx upon 2x will be equal to dy upon minus y. Integrate both sides. So it will come as 1 by 2 ln x equal to minus 1 ln y plus ln c. The constant part y I have taken because it's not a definite integral. Definite integral नहीं है, limit नहीं है, तो आपको लेना पड़ेगा यहाँ पे ln c. Now anything which is any digit which is outside a log, you can take it inside as ln x to the power 1 by 2 will be equal to, now this we can write as ln y minus 1 plus ln c. So ln x to the power 1 by 2 will be equal to ln c by y. That is ln a plus log b will be nothing but equal to log a into b. So that I have written c by y. चलिए, so अब मैंने दोनों साइड का log हटा देना है, क्या बचेगा आपको? x to the power 1 by 2 into y will be equal to c. Take a square, it will be x into y square will be c square something, and that we can write as again constant only. So xy square equal to c. Any equation is there? Yes. Option B. That is your answer. कितने आसानी से बन गया क्वेश्चन. Very easily you have solved this question. Anybody having any doubt in this question, they can ask me. आप लोग का D कैसे आ रहा था? रोहित, खुशबू, अमन, मनीष, how you guys are getting D? D कहां से आएगा? No, you are completely wrong now. How can you get D? Is it clear now? This question you have understood how to approach this type of question. I hope you have cleared. किसी को इस प्रॉब्लम में डाउट है तो बताइए. Anybody having any doubt in this problem, they can ask me. As you can see, whatever we are discussing now, problem will come from that point only. No new concept will come. But you have to practice. You have to think. एक क्वेश्चन बनाने से सारा क्वेश्चन नहीं बन जाएगा. You have to practice also. And that is the reason every Sunday I am going to take workout session. ठीक है? चलिए. So आज की क्लास यहीं तक रखते हैं. You all guys are knowing that Saturday, Sunday FM lecture will not be there. FM lecture नहीं होगा आपका. From Monday, the new timing will be 7:30 to 9:30. Once again, I am telling to all of you, 7:30 a.m. to 9:30 a.m. from Monday, 5th October. 5th October. 7:30 to 9:30 ये आपकी टाइमिंग रहेगी और 2 घंटे की क्लास होगी. नाउ क्लासेस विल बी फॉर 2 hours एंड एवरी संडे 1 to 3 p.m. FM वर्कआउट सेशन. ठीक है. और मॉर्निंग 7 a.m. to 1 p.m. Saturday क्रैश कोर्स. तो कल मिलेंगे हम लोग. Tomorrow we'll again meet at morning 7 a.m. I think most of the guys are free because Saturday Sunday आपकी कॉलेजेस नहीं होती हैं. So tomorrow 5-hour session for environment. It will be a crash course especially for gate aspirants, especially for gate aspirants. So every Saturday I will take 5 hours and then Sunday we will have a FM workout session. Sunday को आपका वर्कआउट सेशन जो ऑलरेडी लिंक मैंने आपको भेज दिया था. Again I will put this link in the same comment in the same video in the comment section में आपको लिंक डाल दूंगा. ठीक है. मिलते हैं नेक्स्ट क्लास में वर्कआउट सेशन में. आप सब लोग रिवाइज करके रखना. The question will be up to this. Up to आज तक जो भी मैंने पढ़ाया है, whatever I have discussed up to this, I can ask any question. Up to this, I can ask any question. चलिए, with that guys, bye bye, take care. If you have any doubt regarding anything, you can always message me through my Facebook and all. Wherever you are comfortable, you can always message me. Please try to clear all your doubt as early as possible. Clear है? चलिए, clear है? चलिए. कल मिलेंगे मॉर्निंग 7 a.m. बी रेडी गाइस विद द एनवायरमेंटल इंजीनियरिंग कंप्लीट क्रैश कोर्स. अगर आपने कर लिया है, जितने घंटे का मैं क्रैश कोर्स करवाऊंगा, अगर आपने कर लिया है, सो आई कैन मेक श्योर यू दैट कि आउट ऑफ 12 मार्क्स जो एनवायरमेंट का आता है, आपको 8 to 10 मार्क्स तो आ ही जाएगा. 8 to 10 मार्क्स यू विल डेफिनेटली गेट. दैट आई कैन टेल यू. दैट मच गारंटी आई कैन गिव इट टू यू. क्लियर है? चलिए, विद दैट गाइस, बाय बाय, टेक केयर. And you guys are not sharing. मैं आपको बता रहा हूं, शेयरिंग इज केयरिंग बच्चा. You guys are not sharing. आप में से कितने लोगों ने शेयर किया? ऑनेस्टली पूछ रहा हूं मैं. How many of you guys have shared with this lecture with your classmates, friends and all? Nobody has shared, I think now. Please share all lectures of this channel and especially fluid mechanics and all. You can definitely share with all your friends and classmates. Chaliye, with that guys, bye bye, take care.